Okay, so in sections 5.3 and 5.4, we are going to take derivatives of exponentials and logs. So we are going to do several examples with logarithms, and then we'll move and do several examples with exponentials. To find the derivative of a logarithm, so the natural log of x, the ln of x. If f of x is the ln of x, then f prime of x is 1 over x. And this general rule, which is the log rule with the chain rule, what we're doing is you have the ln is the outside function and then g of x is the inside. So you do the same thing that you did with the chain rule. You do the derivative of the outside, leave the inside alone. So 1 over the inside times the derivative of what's inside. So 1 over the inside times derivative of the inside. So that's the basic rule, and obviously we're going to mix those with quotient rules, product rules, etc. So let's just start. We're looking at y equals x squared times the ln of x. This is going to be a product rule. So y prime is going to be first function times the derivative of the second. The derivative of the ln of x is 1 over x. So first one's derivative of the second plus the second times the derivative of the first. And we don't have to simplify, so we're done there. On number 2, we're going to have a quotient rule if we have top and the bottom functions here. So y prime would be bottom times the derivative of the top, or ho d high, minus high d ho, the derivative of the ln of x is 1 over x, all over ho ho, or the ln of x quantity squared. Again, we do not need to simplify in Hawks or anything, so this is good enough. Here we have this mess of a function inside. So y prime is going to be 1 over the inside times the inside prime. So we're looking at 1 over 3x to the 4th plus 7x times the derivative of that. So 12x cubed plus 7. All right. Then on number 4, it's a similar problem. So y prime is going to be 1 over the inside times the derivative of the inside. All right. Number 5, we have this chain rule thing. So y prime is going to be exponent down front, decrease it by 1 times the derivative of what's inside. And then another chain rule in number 6. So y prime is going to be exponent down front, decrease it by 1 times the derivative of what's inside. So that would be 2 for the derivative of 2x minus 1 over x. Again, we do not need to simplify, so that is good enough. Okay, so that's not too terribly bad. Sometimes they get messier. You can use algebra to split them up if you wanted to. That could make the derivatives easier. It doesn't have to, but so I'll show you this one 2 different ways. So we're looking at, if we split this up, this would be y equals 3 times the ln of x squared minus 4, which would be 3 times the ln of x squared minus. Is this okay to do it like this? I think so. Oh, no. We need multiplication inside to split it up. X squared minus 4 would be x minus 2x plus 2. So then we have this. We have multiplication inside, so we can split it up with addition outside. And then take the derivative. So y prime would be 1 over the inside times the derivative of the inside, which is just 1. Same thing here. 1 over the inside times the derivative of the inside. That 3 is just hanging out, so just write it down and move on. But that would be your derivative. Or you could do what we did a minute ago. So do like a chain rule. So exponent down front, decrease it by 1 times the derivative of what's inside. Oh, I've done that wrong. Did I do that wrong? Okay. So on this one, we pulled the 3 down in front and then saw this is the difference of perfect squares, so we factored it. And then we have this product, so we can split it with addition and then take the derivatives of the parts. Or we can move that 3 down front, and we're looking at 3 times the ln of x squared minus 4. And then we can take a derivative from here. So just copy that 3 down, then 1 over the inside times the derivative of the inside. And those don't look equivalent, but they are. If you were to get a common denominator and stuff, it would be x minus 2 times x plus 2. And things on the top would work to get you a 6x up on top. So anyway, those are equivalent, 2 different ways to do the same thing. Yeah. Number 2, we have the ln of x squared times 4x minus 1. So again, you have multiplication inside, so you can split that. So we have the ln of x squared plus the ln of 4x minus 1. And then we can take derivatives. So y prime would be 1 over the inside times the derivative of the inside plus 1 over the inside times the derivative of the inside. All right. This next one's kind of messy, but that's all right. We're going to do, I'm not sure how we would go about simplifying here. I don't think that we can. So we're going to do y prime equals denominator times the derivative of the numerator. So 1 over the inside times the derivative of the inside, which is 5, minus the top times the derivative of the bottom, all over the denominator squared. Boy, that's something. Okay. Number 4, we're going to find the second derivative of this thing. I'm going to do this in pieces. So y prime is 2x plus 3 plus 0 plus 1 over x. And then y double prime would be 2 plus 0. This is the same thing as x to the negative 1. So the derivative would be exponent down front, so the negative, decrease it by 1. So you're looking at 2 minus x to the negative 2. And that's y double prime. Okay, so that is exponential derivatives of logarithms, natural logs. So then if we talk about taking derivatives of exponentials, they're easy. The derivative of e to the x is just e to the x. If it's e to some function, then y prime is e to that function times the derivative of that function. I always say e to the u du. So e to the u du or e to the u times u prime. Okay, so y prime for y equals this product. So first function times the derivative of the second. So that's just e to the x. The derivative of e to the x is itself. plus the second function times the derivative of the first. So it's a 4x cubed. That's it. For this one, we are going to do a quotient rule. Y prime is the bottom times the derivative of the top plus the top times the derivative of the bottom, which again, the derivative of e to the x is just e to the x over e to the x squared. Oh, I'm sorry, e to the x plus 1 squared, the bottom squared. Then if you plug in a 2, we have e to the 2 plus 1 times e to the 2. That's minus ho d high minus high d ho. Bottom ho d high minus high d ho. Yeah, there we go. Sorry about that. Guess you could get a decimal approximation in your calculator, but there is f prime of 2 or y prime of 2. Okay, so y prime here on number 3, this is some function u or g of x or whatever. So the derivative is e to the u and then times du or u prime, right? So e to the x squared plus 3 times 2x. Same thing here, y prime, just copy that 8. It would be e to the u times du. So this thing prime. I noticed that a lot of y'all were writing things like this or intended to be writing things like that on the test. So I can do that too to try to help. So we have e to the negative 3x times a negative 3. Number 5, chain rule. So 3e to the x plus 2 squared. Exponent down front, decrease it by 1. Leave the inside alone. Times the derivative of the inside. The derivative of e to the x is e to the x. Let's see if we keep going. Boy. F prime of x, we're going to do exponent down front. Decrease it by 1, leaving the inside alone. Times the derivative of the inside. This is kind of a mess. Let me scoot this over. Okay, so now we're doing, I told you I was going to do this and then I stopped. This prime. So we have 1/2 2x minus e to the 3x to the negative 1/2 times the derivative of 2x is just 2. And then the derivative of e to the 3x is e to the 3x times the derivative of this thing. So just 3. Okay. And then there are some examples to work through. First and second derivatives of negative 7x squared times e to the x. So y prime. The first one is going to be a product rule. So first function times the derivative of the second. The derivative of e to the x is just e to the x. So first function times the derivative of the second plus the second times the derivative of the first. So we're looking at negative 14 times x, exponent down front, decrease 1. There's your first derivative. Now, the second derivative gets messier. It would do you some good to simplify this first derivative before you take the second, because right now that would be 2 copies of the product rule. That's kind of messy, but if I factor out that e to the x, I have negative 7x squared. Actually, let me factor out a negative 7 e to the x. Then I have left here, what negative oh, just positive e to the, nope, x squared, sorry. X squared plus 2x. Let's see, if I redistributed that, I would get negative 7x squared e to the x, good. If I redistributed this, I would get negative 14x times e to the x, yep. Okay, so this then allows me to just do one iteration of a product rule instead of two. So y double prime would be first function times the derivative of the second, which would be 2x plus 2, plus the second times the derivative of the first, which would just be itself. And that's it. Okay. Find f prime of e for f of x. Okay. F prime of x is equal to ho d high, the derivative of e to the x is itself, plus high minus, goodness gracious, minus high d ho, the derivative of the ln of x is 1 over x, all over the denominator squared. If I plug in an e there, it would be the ln of e times e to the e minus e to the e times 1 over e divided by the ln of e squared. The ln of e is 1, so those are good. E to the e over e, that's e to the e minus 1. This has an exponent of 1, so you subtract it from e because of the division. And then that e to the e is by itself. So you're looking at e to the e minus 1 over 1. All right. Let's see. Here we increasing and decreasing for this function. So y prime, increasing, decreasing, we need to do like first derivative test kind of thing. Or a y prime number line. Figure out where the derivative is positive or negative. That tells us increasing and decreasing intervals. So y prime is going to be 2 e to the 2x minus 4 times 1, or to the first exponent down front, decrease it by 1, leave the inside alone, and then times the derivative of the inside. So times e to the 2x times 2, e to the u du. Holy, okay. So we have 4e to the 2x, excuse me, times e to the 2x minus 4. We sure do. And so we want to set this equal to 0. This guy is never 0. E to the 2x would look like this, and not touch 0. If we set this equal to 0, and then we need to solve that equation for e, we would take the natural logs on both sides. Sorry, let me get some space. So then these cancel and we have 2x equals the ln of 4, or x equals the ln of 4 divided by 2. And then you want to do a y prime number line with that value. Oh my. My test values I put on here are 0 and 1. And when I plugged in 0 and 1, I got a negative over here and a positive over here. So we have increasing from the ln of 4 divided by 2 to infinity, and decreasing from negative infinity to the ln of 4 divided by 2. Okay. Lastly, number 4, we have the demand for a project given by d of x equals 140 e to the negative 0.05 x. X is the number of units sold in a week. X is between 0 and 30. Find the number of units sold that will yield the maximum revenue, and find the price per unit that will yield the maximum revenue. So revenue is going to be x times d of x. So we're looking at x times 140 e to the negative 0.05 x. We're trying to maximize revenue, so we want to take a derivative. So we have first function times the derivative of the second, so 140 e to the negative 0.05 x times 0.05 negative. First function times derivative of the second plus the second times the derivative of the first. So I am going to factor out this e to the negative 0.05. 140 times that actually. So what's left in here would be x let me do that. 140 times negative 0.05 is negative 7. So I'm going to now take out the e to the negative 0.05x. I have negative 7x plus 140 left inside. And the point would be to set this equal to 0. This guy is not ever 0. We set this equal to 0. So you get 7x equals 140. So x is 20. So since this is a closed interval, I am thinking we need to do absolute max, not relative. So I'm going to do r prime of 0, r prime of our critical value, which is 20, and r prime of 30. I need to get a calculator out for that. If I have sorry for this, you don't have to listen to me do this in a calculator. Okay. When I plug in 0, I get 140. When I plug in 20, I get 0. Oh. When I plug in 30, Oh, you're not supposed to plug this into the derivative when you do absolute extrema. This is why my answers don't make any sense. When you do absolute extrema, you plug into the regular function. My goodness, I was very confused. Okay, so when we plug in 0, we're plugging in here. So if we plug in 0, it'll make everything go to 0. If we plug in 20, we would have 20 times 140 e to the negative 0.05 times 20. That is 1030.06. And then do it again with 30. $937.15. So this is the maximum revenue. So find the number of units sold that will yield the maximum revenue. So we need to sell 20 units. And then find the price per unit that yields the maximum revenue. You just take 1030.06 and divide by 20. 5150. Approximately that. Okay. So that is 5.3 and 5.4 exponentials and logs. Let me know if you have any questions. Sorry, some of that was rocky. I disagreed with my own notes on that and needed to do some stuff on the fly. But I hope it makes sense. Let me know if you have any questions, and good luck with the homework and stuff. Again, I'm around to help you if you need it. Just reach out. Thank you.